Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. So we have started a new series called Java Training Program in 1 week. We'll be bringing you Java tutorials on each alternate days. So stay tuned for the upcoming videos as well. Today we'll be taking you through the day 1 of this Java training program. But before we begin, I would like to take a quick confirmation from the viewers if we are clearly audible and the screen is clearly visible. If yes, kindly type yes in the chat section, and if there are any changes required from our end, please do let us know in the chat section. Alright, I see a lot of positive responses in the chat section, so let's wait for some more minutes so that some more people can join us. Until then, let me tell you guys that we have regular updates on multiple programming videos. So if you are a programmer and if you want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. Also, if you have any queries related to today's topics, please feel free to drop them down in the comment section only and we'll address them as soon as possible. Great. I think we can get started now. Let's go through the agenda for today's video. We'll start our day 1 by going through the introduction to Java programming, followed by the installation of Java in Windows 10. Then we'll see how to install Eclipse on Windows 10. Once we are done with the installation part, we'll start with the first programming topic, which is primitive data type in Java, followed by non-primitive data types. We'll cover certain topics like tokens in Java and data type conversion in Java before we create our first Hello World program in Java. We'll finish this video up by going through another important topic, that is operators in Java, wherein we'll cover the different types of operators present in Java. Once again, I'm mentioning here about the Java development training program, under which we'll be taking you through some important Java topics on each alternate day. So, I hope to see you guys in every video from now on. Let's start with the introduction to Java programming. Over to our training expert.
When we talk about Java, it is one of the most popular programming language out there, and it was created way back in 1991, but it was publicly released only in 1995. It was developed by one of the famous developers of our generation, who is James Gosling at Sun Microsystems, and then later Java was acquired by Oracle, and today Oracle owns Java. Java is very simple and easy to use, and we will look at different aspects of how it is easy and simple to use. It's a write once, run anywhere type of programming language. Again, we will look at details into this particular concept as well. And when we talk about the usage of Java, you can use it to build web applications, mobile applications, desktop applications, even command line applications. And at the same time, you can also use it to build complex applications like gaming applications, building microservices, or building distributed computing, etc. Let's talk about the features of Java. So one of the most prominent features of Java is that it's an object-oriented programming language, which means that everything which happens in Java happens around objects. Objects enable the execution of the program. Objects talk to each other to exchange data and messages. We will look at the concept of objects in details in the upcoming lectures. It's a platform-independent language, which means that, again, going back to the previous point of write once, run anywhere, it basically enables the program to be run on any platform once compiled. So once you have prepared your program and you have compiled your program, then your compiled program can be run on any platform. It is a strong type checking language, which means that it will force you to respect the contracts of the variables to the data types. For example, if you have created a collection which should accept strings, then you can only insert strings in that collection, and it will not allow you to add a number or an integer into that collection. So it's a strongly type checking language. So when you run your program, it's a two-step process in Java. You compile the program and then you execute the program, which we also call as interpretation. So you have a Java compiler and you have a Java interpreter. You first compile your program and then you run the program using the help of Java interpreter. Java also provides automatic garbage collection. It's a really important feature. And if we talk about the languages prior to Java, like C or C++, they did not offer this capability. And this capability made Java really popular because it could automatically find the unused objects and variables and remove them from the memory to free up memory space for the program execution. It also provides multi-threading support, which means that you can build multi-threading applications like a gaming application. If you take the example of a racing game, for example, so there can be one thread which is monitoring your leaderboard score. There can be another thread which is displaying the speed of the car. There can be another thread which is displaying the graphic. There can be another thread which is displaying the sound. So you see all of these threads are working parallelly, and Java provides the support to create such applications using the multi-threading capability it has. Java is secure by default because there are no pointers in Java, so there are no possibilities of having any memory leaks or any reference leaks from the application. Again, if you take the example of programming languages like C or C++, you had the concept of pointers, and we witnessed a lot of scenarios and a lot of incidents where there was a memory leakage happening in the production application, which was really a bad experience for the organizations. So Java removed the concept of pointers totally from its programming language. It's also a very robust language because it provides a really great exception handling framework out of the box, which developers can use and implement to build really resilient applications. So now let us understand how a Java program is run. So at first you basically write your Java program and you store your Java program into a .java file. Then you compile your Java file with the help of the Java compiler. Once the program is compiled, the compiler is going to generate another file, which is a .class file. And this .class file is basically the compiled file, or also known as the bytecode file. So this bytecode or the .class file code can be run on any platform, be it a Linux platform or a Windows platform or a macOS platform or any other platform. To give you some more context, the first two steps where you write your Java program and you compile your Java program can be run on any machine. Let's take the example that you ran these two steps on a Windows machine. So you write your program and you compile your program on a Windows machine, which generated a .class file. Then you transported this .class file to a Linux machine and it also worked there. You transported your .class file to a macOS machine and it worked there as well. And that's what brings the platform independence concept of Java, that you can write the program once on any platform, and once you have the bytecode available, then you can run this program on any other platform of your choice. Okay, so that was about how the Java program execution works and how the platform independence is actually achieved. Now let us spend some time to understand the anatomy of Java. So once you download Java and install Java on your local machine, you will hear the term JDK. Actually, we'll see that in the next lecture, that when you try to download the Java, it will say JDK download. JDK stands for Java Development Kit. So the Java Development Kit is the installation of the Java. This is what you're going to install on your machine. Once the JDK or Java Development Kit has been installed, the JDK will provide a lot of other components as well, like Java Runtime Environment or JRE, Java Virtual Machine or JVM, some class libraries, and some other supporting libraries. So let us understand what happens when your program is run and how these components work together to make sure that your program runs as expected. Let's start from here. So you install JDK or the Java Development Kit, you write your program, and then you compile your program with the help of Java compiler, which is provided by JDK. Once the program is compiled, your .class file will be generated, and then you can run that .class file using JRE. In fact, if you just run your program on your local machine, JRE will automatically kick in and run your .class file. So the Java Runtime Environment or JRE runs your .class file with the help of these three components. Let's talk about first component, which is Java Virtual Machine or JVM. So the Java Virtual Machine is actually the virtual environment inside which your program runs. This is the real main environment inside your .class file is running. So when this program is running, how does it achieve this environment? For achieving this virtual machine environment, it would need some runtime libraries, and that is provided by these class libraries. For example, there would be a runtime jar or rt.jar as a shorthand, which will be supplied to the program at the runtime to make sure that the program runs smoothly. Then there are other supporting libraries as well, which your program may be using. For example, if this program, this .class file is, let's say, a calculator program, then it might be using a square root function from java.math package. So how does the java.math package get supplied at runtime? It would be supplied by the other supporting libraries which are present inside JRE. So JRE will make sure that your program runs inside the Java virtual machine. It gets the required runtime libraries, and it also gets the libraries which are referred in your program at runtime. And this all together will make sure that your program is running. So you can see JDK basically provides JRE automatically and JVM automatically, but you can also install JRE separately. If you talk about that use case where you compile your program on a Windows machine using JDK, and then you exported your .class file to another machine, and there you just install the JRE. You don't install JDK there, you just install the runtime environment, and you can run the .class file just using the runtime environment. Let's get started with installing Java. We will basically look at how we can install Java on a Windows machine. So the first step to install Java is to download it from the official Oracle website. So for that, let's open a web browser and let's type JDK Java download and hit enter. Then you need to find the link which says oracle.com. Java is owned by Oracle, so we need to download it from the official website only. So we can click on this link which says Java SE downloads. It will bring us to the downloads page, and we will see different versions of Java. You can see the Java SE 15, you can see Java SE 14, you can also see Java SE 11 and all the previous versions. Another thing which you will notice that it says LTS here, which means long-term support. Basically, long-term support are the releases for which Oracle is going to provide long-term security patches and updates. For the non-LTS releases, Java will not provide long-term support and long-term patch fixes and long-term security fixes. So it's a good idea to analyze and evaluate on which version you want to develop your applications on. For this demo, I think it is fine. We can go with the non-LTS version. And even for your customer-facing applications, you can start with the non-LTS version and then upgrade to the latest LTS version whenever that is available. So for this demo, we can download Java SE 15, and you can also do the same on your machine. It will work exactly the same way as an LTS works. So you can click on the JDK download option here. Let's click on that. It is going to bring up the downloads detail page, and you can see there are multiple options given here in terms of what platform you want to install Java on, whether it is a Linux platform or it is a Mac OS machine or it is a Windows platform. So like I said in the beginning of the demo, that today we are going to see how we can install this on a Windows machine. So I'm going to download the Windows x64 installer here. If you are working on a Linux machine or a Mac OS machine, you can download those respective installers as well. So you can see the exe here. So let's click on this. Once we click on this, we'll get this pop-up, which will ask us to accept the Oracle Technology Network License Agreement. So we can hit this checkbox and click on Download JDK 15. And this shall start the download, and you will see some exe getting downloaded in your download box here. But as the download is going to take some time, and I'm not going to wait for that, and that's the reason I have already downloaded the JDK 15 for this particular demo, and that JDK is sitting here on my desktop, which I've downloaded prior to this demo. So we'll just run this particular exe, which is exactly the same exe as the one which is being downloaded. So let us double click on this. It will ask you for this pop-up in some cases, so you can just hit yes. Basically, it is asking whether you trust this exe or not. But as we downloaded this from official Oracle website, then we can trust this particular exe. So I will hit yes. And now the installer is going to unpack, and you might get a screen like this, which will be an installation wizard for the Java SE Development Kit 15. Another thing which, before I proceed, I just wanted to highlight that as well, that you might have noticed the word JDK here. It's exactly the same term which we covered in the last lecture, that when you install Java, you basically install the JDK, which is the Java Development Kit. And this is also visible here when it says Java SE Development Kit 15. So let's hit next. Then on this particular page, you have the option to change the installation location of Java if you want to. By default, it is going to install in C program files /java/jdk15. But if you want to change the location and you want to install Java to a particular custom location of your choice, that is also possible. You just hit change here, and then you can choose whatever directory or folder or place you want to install this Java on, and you can basically select the appropriate location. For this particular case, I don't want to change that. I'm happy with the default location, which is available here. So I'm just going to proceed with this particular location here. So I will just hit next. And then Java is going to install. And it's very fast installation. It generally takes few seconds, as you will see in this demo. Basically, it is going to unpack all the libraries and all the runtime libraries and all the class path libraries, which we discussed in the previous lecture, and put all that into the location which we specified to install Java. It will also set up the rest of the prerequisites which are required to run Java successfully. So looks like the Java has been successfully installed, as is visible in this message. And there's also a next step if you want to access the tutorials or the API documentations, the developer guides, the release notes, etc. I don't want to do that, so I will just hit close here. And now if we want to just verify if Java is installed or not, then we can verify that from the command line prompt. Let me just exit this, and let's go to the command prompt to verify to see if Java has been successfully installed. So to do that, we'll just open the search bar and we'll type cmd. It is going to show us this command prompt here. We'll click on this and it will open the command prompt for you like it has opened for me. And there you just need to type Java-version and you hit enter. If you get a message like this, it means Java has been successfully installed. If you get a message saying that Java is not recognized as a command, it means that Java is still not successfully installed and something has gone wrong in your installation. And in that case, you might want to restart. You might want to go back and reinstall this Java exe again. So in this case, it looks like it has been successfully installed. And we can also get some interesting information from here. We can see which version of Java has been installed. It says Java version 15. We can also see that the JRE is also installed. The Java SE Runtime Environment, or JRE, is also installed. And we can also see that the JVM is also installed, which is Java Hotspot Server VM. VM means the virtual machine. So if I connect this back to the previous lecture, we can see that the Java JDK basically installed the JRE as well as the JVM as well. And the complete Java package has been successfully installed. Now we are ready to use Java, a Java program, and run Java programs on this machine. And let's get started with installing Eclipse on a Windows machine. We are going to see how we can install Eclipse so that we can run our Java programs. So the first thing which we need to do is to download Eclipse. So for that, I'm just going to open my web browser and type Eclipse download, press enter. And then you need to find the link which says eclipse.org/downloads, which is the first link in my search results. You can also see it says Eclipse downloads, the Eclipse Foundation. And Eclipse Foundation is the organization which maintains the Eclipse installers. So we can click on this. Once we click on this, we will be redirected onto the Eclipse downloads page. And there again, you will see a bunch of options. You will see the default option highlighted, which would be the Eclipse installer for JRE, for Mac OS, Windows, and Linux. And then you have some other tool platforms option as well, like Eclipse G or Orion which you might want to use for advanced cases. But for running Java applications, all you need is an Eclipse installer, which is coming from here. So based on your machine, Eclipse will automatically detect whether you want a 64-bit installer or a 32-bit installer. And you can just click on this particular link, which says download 64-bit here. So I'm just going to hit download 64-bit. It is going to open this particular screen where, based on your current location, Eclipse will suggest the nearest possible distribution mirror. Distribution mirror is basically a server which is present somewhere in this world, which contains this Eclipse installer exe. And Eclipse has created these servers all across the globes. These servers are basically called the mirrors. And based on your current location, which will be taken from your ISP, from the internet IP address from which you are accessing this particular website. So based on your ISP location, it is going to suggest you the nearest possible mirror location so that your download is the fastest. So in my case, the nearest location is Netherlands here, as you can see, and I get a download option. This is the file name, which says Eclipse installer JRE Windows 64.exe. And if you think that this mirror doesn't make sense, just click on this option, select another mirror, and then you can choose another mirror. But generally it works really well. It works based on your IP location, and it's generally the download speed is pretty good based on the suggested mirror. So I'm not going to change the mirror location because I think this works fine for me. So, and I'm just going to click on this particular button, which is going to start the download of the Eclipse installer. So now I have hit the download button, and you can see right now an exe has begun to download. It is going to again take some time, and I have already downloaded this particular exe just to save us some time, and I'm going to use that exe to showcase how we can install it. Another thing just wanted to highlight is that Eclipse is an open source organization. It works on donations. So if you feel generous about it, and if you feel that Eclipse is doing really great work, you can also donate to it, which will show here. So we can move to the next step, which is about installing. So you can see here, I have an installer here, an exe file basically, which I have pre-downloaded to showcase this demo. I'm just going to double click on this, and it is going to unpack the installer. You can see this icon will be presented to you, which says Eclipse installer by Oomph. Oomph is basically the provider for this particular installer who manages the installer. And based on your computer's capacity and speed, it is going to take few seconds. And in the background, what it is doing is basically it is unpacking this installer and creating all the installation files which it needs to successfully install it on your computer. Once that is done, you will be presented with this kind of screen, and you will see that Eclipse provides multiple different kind of IDEs for different set of developer communities. You will see an option which says Eclipse IDE for Java developers. You will also see Eclipse IDE for enterprise Java developers. You will see the IDE for C++ and C developers, web and JavaScript, PHP, Eclipse committers who basically contribute to the Eclipse organization, or RCP, RAP, tester, scientific computing. There are tons of IDEs which Eclipse maintains. For our use case throughout this series, I think we will be focusing on this particular IDE, which says Eclipse IDE for enterprise Java developers. You can also use this particular IDE, but this is a very bare bone IDE with very limited set of integrations. Like it says, it includes a Java IDE, a Git client, an XML editor, a Maven plugin, and a Gradle plugin. But if you look at the enterprise, you will get more integrations. You can use this particular IDE to work on whatever you work here. So these all will work here. But in addition, you can also use this IDE to build a web application, build a web service, build a JPA application, data tools, Java server pages, faces, etc. So this is more advanced, I would say. And we will go with this particular IDE. And you can also choose this IDE if you want to, but for this demo, we are going to choose this one. I will click on this. Then it is going to show me which virtual machine it is going to use. So if you remember in the previous lecture, we installed Java 15. It has automatically detected that location by reading my C program files folder, and it has automatically taken that. If you have multiple JDK installations on your machine, you can click on this icon and change a different Java virtual machine. I'm going to leave it as is. Again, the installation folder is also by default taken to your C users username /Eclipse /the JEE version number. And again, if you want to change this, you can also change a different installation folder. I'm going to leave everything as default. It will automatically create a start menu entry and a desktop shortcut. And now I hit install. It might come ask you for a user agreement. So you can hit accept now. And now it has begun the installation. The installation generally takes a bit of time to complete in some cases. So again, it depends upon your computer's capacity and speed. Basically, if it's a good robust machine with good capacity, the installation might be very fast, as you can see in my computer. And if you have a computer which is not very strong on configurations, you can just be patient and wait for some time, and the installation will be finished. Once the installation is finished, you will see this launch option here. You will also have an option to keep an installer if you want to, show the README file. But I think the main option here, which we are going to use, is the launch option. So if you hit the launch option, now the actual IDE is going to start up. It's again going to set up some configuration files and some bootstrap configuration files, which it needs to. And then it will ask you to choose a workspace. Again, workspace is up to you. Where you want to create your workspace? The workspace is basically the location where you will create your projects. It will store those project files and the source code of those projects. So it is up to you where you want to create it. Again, I'm going to leave it as default here, but if you want to change it, just hit browse here and choose whatever location you want to. You can see, you can go to PC and you can choose whatever location you want to. I'm going to leave it as is. And you also have a choice that you don't want Eclipse to ask this every time. So you can check this box, and next time Eclipse is not going to ask you to choose a directory as workspace. And every time you start Eclipse, it will automatically go to this particular directory. So you can either check it or uncheck it based on your convenience and hit launch. Once you hit launch, it is going to start the actual IDE as a desktop application, and you will get a nice interface and a welcome screen from Eclipse, which will basically show the basic overview of the screen, something like this. So now you can see that the Eclipse IDE has started. It has a welcome page, which has multiple options. You can check out a project from Git. You can import an existing project. You can go to the marketplace, create a Java web project or whatever, or you can just close this. You have a nice navigation project explorer bar here. So all the projects which you're going to create will be listed here. There are also some quick shortcuts here for creating different kind of projects. And if you don't want to use that, just go to File, New, and choose a kind of project you want to create, whether it is a Maven project or enterprise application project or dynamic web project or just a project. If you just hit just a project, you can choose a basic Java project to start with, click Next, give a project name. Let's call it Test Demo. You can choose an execution environment here, the JRE, and currently this particular IDE has support up to 14, but I think this is going to work fine. We don't need to worry about it. We can also use a project specific JRE, like in this case, Java 15, which is the current installation. So I can use this option because I want to use Java 15 environment because I have Java 15 installed. So you can basically choose whatever option you want to choose. It gives you a flexibility in terms of choosing the JRE, whether you want to choose an external JRE, whether you want to choose a project specific JRE, or you want to use the default JRE JDK installation. So you can use this option as well if you want to. Project layout is either you want to create separate folders for source and classes, or you want to create the use the project folder. Again, these are just basic configurations which you can play around with if you want to. I'm just going to leave it as is and hit next. And then it is going to just give me a review screen here. If I want to change anything, I can. Otherwise, I can just hit finish. I can create a module name here if I want to, but I don't want to create it. So I just hit on don't create and open the Java perspective. And that's it. You have a Java project here where you can create your Java files under this SRC, and you can start executing those files. We will look out on those details in the upcoming lectures. But for this lecture, I think this is what we wanted to achieve. We wanted to show how we can install Eclipse and how we can create a very sample Java CLI project. Let's get started with primitive data types in Java. We are going to learn about the primitive data types in Java, and we'll also see a short demonstration of it. So let's get started. Let's first just learn about those data types. I've just opened the official Oracle documentation, and don't worry if you see how this link appears here. You can just open a browser window and just type Java primitive data types. And if you hit enter, the first link which you will be given is this particular link, and this is the same link which I have opened. So let's learn about the data types now. So Java has these primitive data types, which you can see here. Some of them store numbers, some of them store Boolean values, and some of them store characters. So the data types which store numbers are byte, short, int, long, float, and double. These 6 data types basically are used to store any kind of numeric value. Let's understand these a bit more. Byte is the shortest possible data type value which you can use in Java to store numbers. You can only store numbers within the range of -128 to +127. So you can see the range is very small, and Java has created this variable for use cases where you want to store numbers which have very small value in this range. Why do we provide these kind of options? Just to save memory, because the smaller data type will require less memory to be used in the Java program. Similarly, the next bigger data type is short, which is a bit bigger than byte. And the range of this particular data type variables will range from -32678 to +32767. So that is the range for this particular variable. And you can see that it has a very big range as compared to the byte data type. So if you want to store values which lie in this range, you can use short. The next one is int data type. You can use this one to store even larger values, which range from -2 raised to power 31 to +2 raised to power 31 minus 1. The next one is long, which is even bigger than int, and it can be used to store the values within the range of -2 raised to power 63 to +2 raised to power 63 minus 1. So as you can see, as we go from top to bottom, from byte to long, the size of the value which can be stored using this data type increases. And that's how you will basically take a decision of whether you want to use byte or you want to use short or int or long, based on what size of the value that variable is going to contain. Then the next ones are float and double. These two have been created for the use cases where you want to store the values, numeric values, which have decimals, which are precision values. I should also mention that byte, short, int, and long are only used for storing absolute numbers which do not have any decimal representation. Even if you try to store a decimal value in these variables, they will automatically be trimmed. The decimal values will automatically be removed, and you will only be shown the absolute values. And in case of float and double, they can maintain those precision and decimal values. So we use float for the use cases where you want to store decimal representations of the values. And you can see that the float value can store a smaller precision value, but double can store even a bigger precision value. So if you have really big precision values to be maintained, very big decimal values to be maintained, you should use double. And the float is used for storing a bit smaller size of the precision values. I mean, its range of values basically beyond the scope of this discussion. If you want to read more about this, you can go to these particular links, which will explain this in detail. But the basic idea is that float is good for storing 2 precision values. And if you want to go beyond that, you want to use double. In some cases, some people also use float to store even beyond 2 values as well. So it completely depends. The decision factor is how long the value you are going to store in the decimal. And that will decide whether you want to use float or double. The next one is Boolean, which is used for storing the Boolean values. Boolean values can be either true or false. So there are only 2 possible values. And then we have char, which is used for storing characters. It is using 16-bit to store the value. And this is a very popular Java question for beginner level programmers, that why does it need 16-bit to store the character? It's because it stores a Unicode representation. Unicode representation is the representation which can be accepted across platforms across the world in different character encodings. So let's move on to Eclipse now, where I have prepared a very short and simple demo. I'm just creating a variable for each data type and I'm printing them. You also see some things here like these keywords, and don't worry about these keywords. I will cover these keywords in detail in the upcoming lectures. You also see this. And you can just, for now, you can remember that system.out.println is used for printing anything in Java. Anything you want to print on the console, you would be using system.out.println. What is system, what is out, and what is println? Again, we will cover these in the upcoming lectures. For now, I'm just creating a bunch of data types here, variables here basically. I'm creating a char type variable, a byte type variable, a short type variable, an int type variable, a float type variable, a double, and a boolean. The way you create variables is basically you put the data type name, you put the variable name, which can be anything, you put an equal sign, and you put the value, actual value which this variable is going to store. And I've done the similar thing for all of these variables. Java wants semicolons to be there when you write your statements. So please remember that your statements always end with semicolons. So I've declared all of these variables here, a byte, a short, an int, float, double, and boolean. And then I'm printing all of them basically. Here I'm printing the char variable. Here I'm printing the byte variable. Here I'm printing the short, and so on and so forth. So how do we actually run this application or this program? You just double click on this or right click on this. You go to this run as option. You see this run as Java application option. So you can hit this option. It will run the application and it will present all the output here in the console tab. Let me just bring this up. So you can see all the variables have been printed here, and this is coming from these print statements. Like I said, this is used, system.out.println is used to basically print anything, and I've used that to print all the variables here. First, I'm printing the char variable whose value is a. Then I'm using the byte variable, which is denoted by b and whose value is 2. So you can see the value is 2 here. Then I'm printing the third variable, which is c, which is a short type variable, which has a value 22. You can see short, and this is coming here. The next print statement is int. So you can see int here with the value 45, and this value is coming from here. Then we have float. You can see the float value being printed here, and you can see the float value declared here. You also see an F here, and this is the standard naming convention which Java proposes, that whenever you declare float and double, you end them with F or D based on whether it is float or it is double. Then you see the double value, which is having a bigger precision than float. So I've printed the double value using this particular print statement, which is printed here. And then we have the Boolean value, which is stored as G, and the value of G is true, and the same value is printed here. So whatever I write here basically is printed here. This is just a placeholder, and this is the actual value. So you can see that we are able to use all the variables here, all the primitive variables basically, which range from byte, character, byte, short, int, float, double, and boolean. Let's get started with non-primitive data types in Java. We talked about the primitive data types, and now we'll discuss about some of the data types which are not primitive. First of all, let's understand what is the difference between primitive and non-primitive. So the primitive data types are the ones which are by default supported by Java, and non-primitives are the ones which are a bit custom in nature, where you as developer have the liberty to define the nature of that data type. We'll look at some examples of that as well. But when we talk about which all are the non-primitive data types, we broadly talk about arrays, we talk about classes, we talk about strings as well. And we will cover some of them in today's lecture. And we have a detailed lecture upcoming about the classes as well. In fact, in the after a few lectures, we'll cover how we'll create classes as well. But for today's lecture, we are going to focus on string data type and array data type. And like I said, for classes, we have a dedicated lecture upcoming. So don't worry about that. And again, for this particular case as well, I have already prepared a demo for this, and we'll basically do some look at some hands-on examples to see how do we create these variables, what does these variables mean. And the first non-primitive data type we are going to talk about is string. And before I go on further, I should also mention that it's very debatable in the Java community to call string as a non-primitive data type. And actually, technically speaking, string is a special data type. It neither fully lies in the primitive category, nor it fully lies in the non-primitive categories. I'm covering this as a non-primitive data type because it's a bit inclined towards the non-primitive category. Why do we do this? Is because Java does provide native support for string handling in the JDK. And that's the reason some of the developers feel that string is a primitive data type, which is primitively supported by Java. But at the same time, string is so customizable and it's so special in nature. It's the way it stores the value, the way it provides the operations and handlings. It's so different than primitive data types that it cannot fully be put in the same bucket as the primitive data types. So that's why I said it's a special data type, a bit inclined towards the non-primitive category. So what is string basically? We covered about the char data type in the previous lecture, and in char data type, you can only store a single character, right? But if you want to store a complete name of somebody, then it's a list of characters. It's basically a lot of characters together. Then in that case, you would need a data type to store that continuous sequence of characters. And that's what string does. String can store a continuous sequence of characters. Technically, string is basically a character array. You can call string as a character array. And don't worry if you don't understand about the word array. I will explain that in the same lecture. So basically, it stores the continuous sequence of characters. That's how we define string. And you see this string, this is basically the keyword, the data type basically in Java. So whenever you want to create a string, you need to write string with S capital. You need to give a name to the string. This can be anything. And then you can provide the value, which this particular string is going to contain. So you can see this is a continuous sequence of characters. T, E, S, T are the 4 characters which this string is going to contain. And after that, again, I'm printing this particular value. And like I said, don't worry about this. We'll cover this when we'll write our first program in Java. So this is just to print the string value. I'm just putting a string placeholder here, and then I'm actually printing the values of the string variable. Now, string can be created in multiple ways in Java. This is one way of creating it. There's another way of creating a string variable, which is this one, which says, again, the string data type, some variable name, a keyword called new. Again, don't worry about what is this new keyword. We'll cover this when we'll talk about running our first program in Java and writing the first program from scratch. Then we again say string, and then we provide the value. So if I compare this line number 4 to line number 7, you can see the difference is that I'm still storing the same value, test, but the difference is that here there is no new string keyword, but here we have this new string keyword. So what is the difference? The difference is this, that in this case, in this particular case, string is going to reuse the same object multiple times. But in this case, every time you call this, it is going to create a new object. Again, what is object? It's just, you can think of it as, for now, you can think of it as a memory block. We'll again cover objects in details. But these are two different ways in which you can create string. This is generally the most popular way of doing it because this is memory efficient, because you can reuse the same variable again and again. So I'm creating the string variable here and creating another string variable str1 here and printing both of them. Then I've created this strange looking thing here, which is basically an array. Array, like I said, is also a non-primitive data type in Java, and array can store a continuous sequence of anything. That anything can be a number, that anything can be characters, that anything can be a floating number as well. So basic idea is that if you want to store a collection or a sequence of multiple values, how do you do that? You do that with the help of arrays. Array is a data structure, a non-primitive data structure in Java, which can store a lot of values of similar type. We also call it as homogeneous data structure, because it can only store same data type values or homogeneous data type values. So the biggest way to identify array is this square bracket. Whenever you see this square bracket in Java, it means it's an array variable. So here I am creating an integer array variable with the name ARR. This is the name of this particular array. It is only going to store integer values because I've specified int. And the moment I provide the square brackets, it means that it is an array. So you can declare an array like this, and then you need to assign a size to the array. Size is basically denoting how many values this data structure is going to store. So I'm saying new, again, it's a keyword, and I'm saying that, okay, create a memory block for storing two integers. So this particular array ARR can store at max two values at continuous locations. The next thing about array is that it stores the value in a zero index based location. So like I said, it can store two values. So the first location will always be array of 0, and this is how you specify the location or index of the element which is going to be stored. So at the 0th location of this array, I'm storing 0. The first location of the array, I'm storing 1. And this is just to show an error scenario, but I will just comment this for now. You can just put double slashes and comment any line. So I'm just storing, filling up this array for two values, and the two values location would be 0 index and first index. These are just continuous memory locations, and we denote those memory locations as 0 and 1. Array indexes always start with 0, and I'm just putting some values here. You can put any values. And then I'm printing the whole array, and I'm also printing the first value of the array. And we'll see how this pans out, and we'll also see how we can change this. So now we are going to run this application. So I'll just go to run as and click on run as Java application. And once I hit that, I get this output here. So let's understand this output. The first one is I'm just printing the string, which has the value test. And you can see it has printed here. It is coming from this line. Then the next line which is printed is line number 8, where I'm saying another string str1, and str1 also had the same value. So you can see another string has the same value. And then I have printed the array here, the complete array. And you see this strange value here. It also tells us that if you want to print the array, then you cannot just put the variable name and print it. The reason is because this is a non-primitive data type. And once you do this, it is basically printing the memory footprint of this array, the whole memory location where this array is stored. That's why you see this strange looking number, which is the memory hash code. And if you want to print any particular value or any particular element inside this array, then you can do that by providing the index location of that element. So here I've said that print the 0th location element of the array. The 0th location array element of the array was 0. So you can see the value 0 here. Let me put some other value just for fun and show you how this works. So I've just changed the values, and now let's see what do we get for array 0. You can see now I get value 3 because now at the 0th location, the 3 value is being stored, and that is what is being printed here. We can also print the first value. I'll just go run as Java application. You can see now the array of first index is being stored, which is basically technically the second element of the array. But because array always works on a 0 index based value format, that's why when we say array 1, the second element is printed. When I say array 0, the first element is printed. So always remember that array is a 0 index based collection or data structure basically. What happens if I do this? Now there is no third element in this array because the array has the size only of 2 elements. And when I say ARR of 2, which means I'm trying to print the third element in this array, which does not exist. So let's see what happens in that case. I get an exception. Exception is basically an error. I get an error saying that index 2 is out of bounds for length 2. It means that the array length was actually 2 and index 2 does not exist. Remember, it's saying index 2, not the element 2. Index 2 doesn't exist because only index 0 and index 1 exist. This makes 2 elements, and the actual size is also 2. It does not have capacity to store third element. It does not have third element location anywhere. That's why it complains that you are trying to print a non-existing value. And let's get started with tokens in Java. When we talk about tokens in Java, these tokens are basically some reserved expressions or words or symbols which have a predefined meaning in Java. And you cannot override this meaning because this meaning is already defined by Java, and you can use those expressions, those symbols, and those words in only the way Java wants you to. There is no way you can change the meaning of those terms or those symbols. So we will be covering those tokens in today's lecture. These tokens are broadly divided into 5 different categories. These categories are keywords, identifiers, constants, special symbols, and operators. So let's talk about each of them one by one. So when we talk about keywords, these are the words which are reserved by Java and they have a predefined meaning. You might have already seen some of these reserved keywords. For example, we have used int when we were working on the primitive data type lecture. We have seen this as well, though we haven't actually found out the meaning of this, but we will find out the meaning of this in the coming lectures. So don't worry about that. We have seen Boolean as a data type again. We have seen byte. So these Boolean, byte, int, class, char, catch, super, switch, synchronized, all the keywords which you see here, these keywords have a predefined meaning in Java. And you use these keywords so that you want to take an action, an expected action by Java. For example, if you call something as int, then you want Java to treat it as int. Int will only have a single meaning in Java, and there is no other meaning of int in a Java program. So that's the intent with the keywords. These are reserved words which have a predefined meaning. And we will cover these keywords at length during this whole course. The next token is identifier. And identifier is nothing but just a variable name technically. And we have already covered this kind of identifier when we were showing the demonstrations for primitive data types and non-primitive data types, etc. It's basically anything which you declare as a variable is an identifier. And when you declare the variable name, again Java puts some sort of restrictions as to what you can or cannot do when you work with Java and you declare the variable names. For example, these variable names cannot start with numbers. So you cannot have a variable name which starts with any number. You cannot have a variable name which contains spaces in between them. You either have to fill those if there's a variable name which you think has two parts, for example student name, then you need to write it as student underscore name so that you can create the variable name with the same impact and still does not contain space. So spaces will not be allowed when you create the variable names. Similarly, you cannot have plus, hyphen and ampersand in the variable names as well. These are the restrictions which Java puts on the identifier tokens whenever you create identifiers. The next one is constants, and we will cover these constants in detail in the coming lectures as well. But to give you an idea of what constants are, so constants are basically exactly what they sound like. They are the identifiers which you have declared in your program whose value cannot be changed once defined. So if you write something as final int I equal to 5, then this value is fixed. You cannot change the value of I again in the program. Java will not allow you to change the value of I again because I has now become a constant because you have put a final keyword in front of it. And again, final is a keyword, you see, final is a keyword basically. So these constants are treated specially by Java, that Java will make sure that their values will never change during the course of the execution of the program. These can come really handy when you have situations where you do not want the certain variables values to be modified. For example, if you have an application where you are counting the number of applicants, and if you have declared the number of applicants as final, then every time you call the application, you can do a +1 to the previous value. The value will not be reinitiated. So it is very useful concept, and it can be very handy in programs where you don't want to change the values. The next is special symbols. These special symbols are the symbols which again have a predefined meaning in Java. We have already seen this square bracket symbol in our previous lecture when we were creating arrays. So whenever you use these square brackets, then Java would understand that you are trying to either access or create an array, or you are trying to access or create a list, etc. So this is predefined. You cannot use this anywhere else or with any other meaning. Similarly, when we talk about these braces, these standard brackets or standard braces, these again have a predefined meaning in Java. Generally, whenever you will write functions and methods in Java, you will use these brackets to define the parameters of the function. Now you cannot use these brackets in any other meaning in Java. Java will not allow you to use this anywhere else apart from using it in method parameters. Similarly, the next one is the curly braces, and the curly braces are used to define a code block in Java. you might have already noticed that when we were looking at the previous demos, you could see some curly braces, then some code, and then the curly braces would end. For example, if I show you here, it's just a sample example, and let me open the example which we covered in the last lecture. So you can see this curly brace here, and this curly brace ends here, right? So this defines a code block in Java. Any code block which you want Java to understand will always be starting with a curly braces and ending with a curly brace. Remember I talked about the standard braces. You can see these are the standard braces, opening and ending, and this is where we are defining this particular method's arguments. Now what is method, what is argument? Don't worry about that. We will cover in detail, but just an introductory concept. Whenever you are trying to define a method and you want to pass any argument to the method, you use these brackets to do that. Okay. Similarly, this is semicolon is used to close any Java statement. So you will see this semicolon here. Every Java statement has to have a semicolon as ending, otherwise Java will complain that it is a syntactical error. So it is part of the syntax. You need to put the semicolon, and semicolon has only one meaning in Java, which is that your statement is actually ending. Then we have star, and star is used for multiplication, and then we have equality, which is used for assigning any values. And again, assigning any values is everywhere. You are seeing this equality sign everywhere. So these are all tokens basically. The last type of token we have is operators, and we will cover these operators in the upcoming lectures in detail with the examples. But these operators are basically some special symbols, like for arithmetic it would be plus, minus, multiplication, divide. For comparison it will be greater than, less than. For logical it would be ampersand and pipe operators. Bitwise again will have some bitwise operation operators. So these are basically different categories of operators, and under each category of operators there are certain symbols. Like for arithmetic we have plus, minus, we have for comparison we have greater than, less than, etc. So these again symbols are also reserved by Java under the operators tokens category. You cannot use these in any other meaning or in any other way. And like I said, we will look at a detailed example of this as well. So this was a quick overview of what are different types of tokens in Java. So we have keywords, we have identifiers, constants, special symbols, and operators. And let's get started with data type conversions. So when we talk about data type conversion, the whole idea is to basically answer the question that whether I can convert a int data type variable into a long data type variable, or a long data type variable to a float data type variable, and also vice versa. Can I go back? Can I convert a float variable into a long variable or an int variable, and vice versa? So this lecture is about answering all of those questions, and we will basically look at some examples to understand how the conversion works. But let me just explain the basic principle. The basic principle is that smaller box can fit into larger box, but if we have to fit a larger box into a smaller box, you need to do something else. So what do we mean by smaller box and larger box here? The smaller box is a variable or a data type which has a smaller range. If you remember, we talked about the range of short, byte, int, etc. And we could see that as we go from short to byte to int to long to float to double, the ranges were increasing, right? So we will follow the same kind of analogy, that if we have to store a smaller range variable into a larger range variable, Java will automatically do that. But if I have to store a larger range variable into a smaller range variable, then I have to sacrifice some quality of the value. And we will look at the examples of that as well. So let's first look at the example where we can store a smaller range variable into a larger range variable. We call this as implicit data type conversion. So here you can see I have declared an int variable with the value 100, and I'm printing the int variable. Then I have declared a long variable, and what I'm doing that I'm assigning the value of int a to the long variable b. So I'm not assigning a new value to this long variable, but rather I'm just passing on the existing integer value into a variable of type long. Similarly, after that, I am taking the value of this variable of long type and storing this value into a float type. So you can see int is basically smaller than long, and long has a smaller range than float. So I'm just storing a smaller range variable into a larger range, and then a larger range variable into the largest range. And then I'm printing all the variables values to see if this actually is working. Can long automatically store the value of A, and can float automatically store the value of B? Here I'm just printing the variables, and again using the concept of the previous lecture, this is just to print the values, and I will cover this in detail in the next lectures of how this works. But here you can understand that we can use system.out.println to basically print the values. And here I'm just printing a string and then the value, then again the string and the value, and here also the string and the value. So this is what is happening in this program. And again, don't worry about these details. I will cover about what these concepts are in the upcoming lectures. So let's run this and see if the data type conversion actually works. So I will just right click and do run as and go to Java application. And if I click on this, I get this output. So the first output is pretty straightforward. I'm just printing the int variable as is. So this works. Then I am storing the int into a long and printing the long representation of A, which is B basically. And this also works without any errors or any warnings by Java. Similarly, when I talk about storing the long variable into a float variable C, this also works. But here you see an additional decimal precision here, because as we remember from the previous sessions, float is used to store values which have decimals or which have precisions. So it will automatically convert your absolute number into a number which has decimals whenever you try to cast this into float. Casting is also a word which is used. Some people call it as implicit data type conversion. Some people call it as implicit data type casting. So if you hear the word data type casting or implicit data type casting, you can think that it is exactly the same concept as data type conversion. So this is about implicit data type conversion. Now let's look at an example of explicit data type conversion. How does that work? So using the same analogy of the boxes, now I will try to store a larger ranging value variable into a smaller range variable and see how that looks like. So I will start with the largest, which is double variable. So I have created a double variable, and as we know that double is a variable which is used to store decimal values. So I'm storing this value here, and then I'm just printing the double representation as is without any changes. Then I'm trying to store this variable's value into a float variable. So I'm trying to go to a smaller box now. I'm trying to go from double to float. And if you remember, I told you that if you have to do that, it will not work out of the box, but you have to do a bit something special as well. And this is the special part. This is called type casting. Type casting is basically a way to tell Java to explicitly cast this variable's value into this data type's variable's value. And you always need to do this whenever there is no implicit casting happening. If you are trying to store a larger value variable into a smaller value variable, you have to do this, otherwise Java will complain. You will get a compilation error. So that's what I'm doing. I'm telling Java to store the value of A as a float and store the value in F. And this is where I'm telling to store the value as float. So you just put brackets and you define float, and then I'm printing the float representation. Similarly, in the next one, I am trying to store the value of this double variable into a long. So you can see now I'm trying to go even from a precision data type to a non-precision data type, because long does not understand decimal values. So I'm trying to store a variable which has decimal values into a variable data type which does not understand decimal values. And we will see how the output looks like. But here also you need to do the explicit casting. Explicitly you need to tell which data type this A needs to be converted into. That's what I do here, and then I print the long variable here. And then next I will again go down further and I will try to store a larger long variable type into a smaller int variable type. So again I'm trying to store the value of B into a smaller data type which is integer, and I'm naming the variable as C. Here again I have to do this explicit casting. I'm telling Java to explicitly cast the value of B, which is a long data type variable, into an integer C, which is an int data type variable. And then I'm just printing the value. So this is what is happening in this program, that from double to float to long to int. Now let's run this program and see what happens. So I will right click and go to run as and choose the Java application option. And this is the output I get. First of all, for the double representation, the value gets printed, 0 is ignored. Then in the float, it works fine as well without any precision loss, because float can also print values up to 1 to 2 decimal points without any problems, even beyond that actually. So it works fine. Then when we talk about the long representation, we are trying to convert a double variable into a long variable, and we see that the precision, the decimal values are lost. This is expected because long does not understand decimal values. That's why anything after the decimal, or in fact the whole decimal portion, is gone when you're trying to store double or float into some absolute data type variables like int or long. And then in int representation, since you already have this long can easily be casted to int by just providing this explicit casting, and the int representation also prints 50. So we started from this value and we ended up with these values when we try to store them as long or int. And let's get started with how to write your first program in Java. And today we are going to focus exactly on how do we actually write a Java program. So as we have already covered how you can install Eclipse and how you can create a sample Java project in Eclipse. And once you have created your Java project, so your Java project might look like something like this. You will have an src folder here. So, and under the src folder, you see some namespaces sort of things created here, right? We call these as packages. And in Java, you can think of package as something which can group multiple related artifacts together. This is simply a grouping mechanism, I can say. It's a way to put all the related artifacts to a particular business problem into a certain place. For example, if you are working in an e-commerce application, so you might have created multiple Java files for, let's say, for checkout, and then some more Java files for the filters flow, I would say, then some other Java files for designing the advertisements. So you have multiple Java files, and these Java files now belong to these 3 different domains. So you want to group them together for easy accessibility, for referencing each other files within the code. So if you want to achieve that kind of flexibility, you would group the checkout code files into a single package. You can name it as checkout package. Then you can similarly do the same thing for the advertisement package and for the filters package. So similarly, I have created some packages here which you can see. You see a package here which says IO GitHub Vikesh Pandey Hello World. And how do you create a package? You just right click on this. So you go to the src and you right click, you go to new, and here you will see this option which says package. So you can just click on this and write anything which you want as the package name. Let's call it as test package. It says invalid because the package is a keyword, so it is not allowing me to put package here, but let's call it test package 1, and you can just click finish and you will see a test package popping up here. Then you can right click on this again, go to new, and then you can create a Java class. Now what is a Java class? A class is basically a blueprint for an object. It's basically the specifications of an object. Like I covered in the very first lecture, everything in Java is an object, or most of the things in Java are object, I would say. So object is basically an instance of the class. So let's say you create a class for, if I take the same example of e-commerce, you create a class for writing the business logic of checkout, and then you create instance of this particular class to work for a particular customer order. So class is basically a blueprint. It's the specification, it's the skeleton of the object. So once you click on this, you can create a class. Now Eclipse is a pretty smart IDE. It will provide you with a bunch of options on how you actually can create a class, and it will also provide you with some sensible defaults. For example, it will automatically select a source folder in your project which you have created. It will automatically select a package. In fact, they currently selected package. And if you want to change the package, just hit browse and choose any other package which you want to choose. So your class file will be created in that package. Then you can provide a name to the class. So let's call it as test hello world. And you can see I have followed a sort of a naming convention here. The first character I've kept it as capital, and then any other new word which is coming in my class file name is also capitalized. So Java would expect you and it would encourage you to follow this naming convention, that whenever you are creating a class, always start with a capital letter, then small letters, and every new word you are writing can start with a capital letter again. Java will not throw an error if you don't do this H capital or W capital, but it's a good practice. The next thing is the modifier. We are going to cover the modifiers in details in the upcoming lectures, but for now you can understand that anything which is marked as public is accessible to every other Java class in this whole project. That's the basic meaning of making a class as public. Public, as the name suggests itself, it means it's visible to everyone. You can select a superclass, and again we'll talk about this superclass later, but this is the Java lang object is the superclass of all the classes which are created in Java. Again, interface is again an advanced concept, and there are some other interesting defaults it provides. For example, if you want to create a main method. Now what is a main method? We'll just cover it in a while. So I will not do that. I will leave everything as default and I will click on finish. So I have this new file coming up here, and you can see it has automatically picked up the package which I selected, and it has also written public class test hello world with a starting and ending curly braces. In the previous lecture we covered about these curly braces, that all the code block have to be in the curly braces. Whenever you write a Java class, the very first statement Java would expect to have in the class is package name. So make sure that you have package as the keyword and then the actual package name as the package name for that particular class. You can see the package follows a dot convention and it always ends with a semicolon, like all the Java statements end with semicolon. So that would be the first thing which you will write in your class. Second thing is the access modifier of the class. Like I said, you want this class to be accessible to every other file in this project. Then you can mark this class as public. The next thing is the class keyword. You need to write this particular keyword as is, otherwise your class will not be detected. So you write this as class. Then you write test hello world or whatever name you want to write. But make sure that whatever public class name you provide here, that name should match with the file name. These two things should match, the file name and the class name. If they don't match, you would experience weird behaviors as the class will not be compiled or class might not be able to run, etc. So always make sure that whatever file name you provide, you always have a class with that name in your file. So my class structure is ready, but there's nothing here in this class. In fact, you cannot even execute this class, because for executing the class, for executing any class in Java, any class at all in Java, you would need a main method in Java. Main method is the entry point method of the Java. Whenever you are trying to run any application, be it a very small or very large Java application, you would always need a main method in the class, in the project somewhere. And you need to tell the Java runtime to execute that class, and then the class will have a main method and your program will start executing. So always have a main method, otherwise your program will not execute. And how do you write the main method? So you first write public, then you write static, then you write void, and then you write main, and then you provide a parameter to this method as this. Now let's understand what did I actually write here. First keyword is public, because this method has to be public, because like I said, Java runtime needs to be able to access this method. So the similar concept which applied on the class is applied on this method as well, that the entry point method has to be public, otherwise Java will not be able to find this method. So you need to make this method exactly as public. The next keyword is static. You again need to write this keyword as is, and the reason we write static here is because we want to run this particular class without creating an object of the class. Static is again a keyword which we'll cover in the upcoming lectures, but for now you can understand that whenever you want to access something within the class without creating an object, then you need to create it as static. The next is void. Void is basically the return type of this method. The method name is main, and it has to be main. It cannot be main1 or main2. Otherwise, if you do that, Java will not be able to run your program, because it will expect you to write this particular method exactly as what I have written here. No changes at all should be there. If you make any changes, Java program will not run, because it will not be able to find the entry point method, which is the main method. So public, static, void, main. Remember that you need to have this in your program. So void is the return type, which means that this particular program, it will not return anything back to the runtime, because a method can have this capability to either return something or not return something. For example, a method which can add two numbers will return the result of addition, right? So we return the result. Return is the word here. In this case, this method is not expected to return anything, because there's nobody consuming it, right? Java runtime will not do anything with the return value of this particular method. That's why Java will force you to write void here, and main is the exact method name which you need to use. Java will expect you to supply a string array argument. If we covered arrays in bit detail in the previous lectures, and we will cover arrays in the next lecture in very detail. But you can, as we discussed, that array is basically a sequence of characters or words or integers or anything, right? So in this case, this is basically the mandatory parameter which you need to write as is. This parameter name can be anything, obviously. It can be arg, args, or whatever you want to write it as. But the basic fundamental is that Java will basically supply all the command line arguments using this particular string array. That's why you need to provide this. Then let's write something in the program, because this is a hello world program. So I will just write system.out.println, and I'll type a string here which says hello world and a semicolon. So again, I have been saying that I will explain this, and now I will explain this. Why do we need this and what does this mean? So as I've told earlier, that whenever you want to print something on the console in a Java program, you need to write system.out.println. Now system here, if you just hover over it, Eclipse will show what it is. So system is basically a class which contains several useful class fields and methods. It cannot be instantiated, means you cannot create an object of it, and it provides many facilities like standard input, standard output, and error output. Exactly what we want to focus here, because we want to use system class to print something on the standard output. The standard output in this case is the console. So if you want to input something, or you want to output something, or you want to output an error, then you need to use system class. And all of these, standard input, standard output, and error, are streams. And that's what comes to the next word. What is this out? Out is a stream to print standard output. Similarly, we have system.err, which is for printing the error output streams. Similarly, we have system.in for taking its standard input streams. So system.in, system.out, system.err, these in, out, and err are streams. And then println is the actual method. Let's hover over that. Let's first see out here. So you can see this is a stream object which is used to print anything, which is ready to accept output data basically. And then we go to the println method, and it says prints a string and then terminate the line. So like I mentioned earlier as well, this whole syntax is used to print, and actually this is the core method. This is the real method which prints something on the console. So system class uses the output stream to print something on the console using the help of println method. There is also a print method. So there are two methods. One is print and one is println. The difference is that in case of print method, the print method will not provide you or terminate on a next line. But in system.out.println, the ln means line here. It will print something and it will bring the cursor to the next line. If you do not use this, and if you again use another print statement, then both of the statements will be printed on the same line. I will show that as well. But and then we provide any random string here which we want to print. So you right click on this particular program, you go to run as, and you run as Java application, and you want to save this. So you can say always save resources before launching, and you see the output here. So this is how you can run your first Java program. Now let's also see the difference between system.out.println and system.out.print. So I will just copy this here and I'll say hello world 1, let's say. And this time I will not use system.out.println, but I will use system.out.print. Just put a space here so that it's visible. So if I use print, how does that look like? I go to run and I go to run as Java application. So now you see both of the outputs are printed on the same line. There is no, this output hasn't gone to the next line. And now if I run the same program with system.out.println methods, now both of these outputs will be divided on two lines. The first output, then a line break, the hello world 1 goes to the next line. In the previous run, the hello world 1 was printing right next to it on the same line. So that is the difference. So this is how you can build your very first program, the hello world program in Java. And let's get started with operators in Java. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators. Then we have conditional operators and logical operators. And we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work. And we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators. And we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example. And as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project, which I have shown you we created in the previous lectures. So for all the demonstrations, I will just continue in the same project. So again, the way to create a class remains the same, exactly the same as how I covered in the previous lecture in the Hello World program, where we created a class. So here also I created a class. I named the class as arithmetic demo, and I have a public static void main method inside this particular class. And I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result and then what I'm doing that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22. And then again an addition at line 27. And then a modulus at line 32. And I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3, because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result or 3 into this result variable, and we print that value at line 14. So original result plus original result is 3. Then a string here, minus 1 equal to. So this is just a string. And then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2 and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable at line 29. Now the result value should become 10, because 2 plus 8 is 10. And again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34. We are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division, and modulus operators, which are all the arithmetic operators. And let's get started with unary operators. So when we talk about unary operators, technically they are also arithmetic operators, but they provide us a shorthand, or they have a more advanced meaning. So if you see on the screen, these are the unary operators. We call them as unary plus, unary minus, increment operator, decrement operator, and logical complement operator. So when we talk about the unary plus operator, basically it is used to indicate a positive value. So whatever value you are having, it will just make that number as positive number. You might be wondering that this plus has an addition meaning as well, right? Which we saw in the previous example. Yes, that's correct. But when we use that addition symbol, we use that between two variables. But when we talk about unary operators, they are used with a single variable. That is why the name unary, because they are used with a single variable. They require only one operand. So unary plus basically makes any number positive. Unary minus negates an expression and makes that number negative. Increment operator increments the value by +1. Decrement operator decreases the value by -1. And logical complement operator inverts the value of the expression from true to false or false to true. Let's understand this with the help of an example. So I have created a class here called unary demo, and I have a static void main method here, and I have created a variable called result, and the first example is about using unary plus. So I'm creating a variable called as result, assigning the value as 1 and just putting 1 plus in front of it, which makes this as positive value. Though we can argue that this also has the same effect as this, and yes, that is true. But in case if this value was written as something like -1 instead of plus, then we could basically make that number positive by just putting plus in front of it. So that's basically the power of unary operators, and that's how you generally use unary operators. So I'll just put it back to +1. The next example is about decrement operators. So the current value of result was 1 because we did this. Now we are saying result minus minus, which means whatever the value of result is, just decrement it by 1. So the current value was 1. So now the new value of result after this evaluation becomes 0. So at line 14, we print the current value of result, which is 0. Moving on at line 16, we are using the increment plus plus operator here, which means whatever the current value of result is, just increment it by 1. So the current value of result was 0 till this line. So it becomes 1 because this means increment by 1. So line 18 will basically print that value 1. And then at line 20, I'm using the unary minus operator, which means whatever the value of result is, just negate it. Just put a negative in front of it. Just make that number negative. So if I just say minus result, the current value of result was 1. So it became -1. And then to showcase the negation operation, I created a Boolean variable, named it as success, assigned the value of this variable as false, and printed the value of success variable as is first, and then printed the value of success with a negation in front of it, with an exclamation mark, which will basically flip the value or invert the value of a Boolean variable. So if this was false, line 28 should print true. If this was true, line 28 should print false. In this case, this is false, so the line 28 should print true. So let's right click on this and run this program and see if we get the expected output. And yes, we see the output here. So let's try to interpret the output now. The line 10 should print 1. Yes. Then line 14 should print 0. We see 0 here. Line 18 should print 1 because we use the increment plus plus. So 0 plus 1 became 1. Then we use the unary minus operator. So the value should become -1. Yes, we see -1 here. And then for Boolean variable, we should see first the false because the value is printed as is. And then we are printing a negated value. So we should flip the value from false to true. And yes, it is printing the value as true. So this was about unary operators. Now, when we talk about these increment and decrement operators, What if I put this particular value in front of result? What effect is that going to happen? Let's analyze that part as well. So for that, I have prepared a separate demo. Again, I've created a class called pre-post-demo, and it has a public static void main method. I'm declaring an integer variable I with the value as 3. So the I becomes 3 here. And then I'm saying I++. As we have already seen in the unary demo example, this should increment the value of 3 to 4. So it will print 4, expected, right? Then at line number 9, I'm putting this plus plus in front of I. Now what will happen? Now it is going to increment the value of I and then basically assigning the value of I. So the whole difference between I++ and plus plus I is that in this case, the value of I is assigned first and increment later. In this case, the value of I is incremented first and assigned later. So here the value from 4 becomes 5. So at line 11, if you see, if we print I, it will print 5 because we are saying that first increment the value and then update the value of I. So increment happens on I equal to 4 and I becomes 5. At line number 13, it becomes more interesting because here inside the system.out.println statement itself, I'm saying plus plus I. Now what will happen? Like I explained, first the value will be incremented and then the value will be assigned. So before printing, the value is getting incremented. So the value from 5 becomes 6 here at line 13. But if I try to do this, now I'm saying first assign the value of I and then increment it. So I at this line is still 6 because I has already been assigned 6. And as the post increment says, if you put this plus plus after the variable, it means that you are first assigning the value and then incrementing the value. So anything which happens after line 15, the value of I will become 7. But at line 15, the value of I is still 6 because we are using a post increment operator. So the value is still assigned to I as is and then incremented. And when we do system.out.println, the assigned value is printed, not the incremented value. So like I said, after line 15, the value of I will become incremented by 1 and it will become 7. So hope you understood this example and the difference between the pre-increment and post-increment. Remember the thumb rule that if we put plus plus before a variable, like at line number 9, the value will be incremented first and then assigned. So at line 13, the updated value will be printed because the first we are doing the increment and then we are printing the value or assigning the value. Similarly, at line 15, we are first printing the value and then incrementing the value. So when the value is printed at line 15, the old value of I will be printed, but after line 15, the new value of I will be accessible to the program. So let's right click on this and run this program. And now if we see the values, we assigned I to 3. We did a post increment here. So I becomes 4. We print the value of I. So here the value of I is 4. You see 4 here. Then at line 9, we are saying plus plus I. So 4 plus 1 becomes 5. Though this is a pre-increment, but since we are not printing this plus plus I as is, it does not have any change. So the value of 4 becomes 5. At line 11, we print 5. Then at line 13, we are saying plus plus I, which means increment the value of I first and then assign it. So the value of 5 becomes 6 and then I gets updated and printed. Similarly, at line 15, first the value of I is assigned and printed and then incremented. So at line 15, the value is still 6. You see this 6 here, and then the value is incremented. So after line 15, the value becomes 7.
And let's get started with equality and relational operators. When we talk about relational operators, they are sometimes also called comparison operators. And the basic idea behind using these operators is to compare things or compare the values of variables or compare the objects in Java. So in Java, if you need to compare anything, for example, if you want to compare if something is less than the other thing, or something is greater than the other thing, or something is equal to the other thing, then you need to use the comparison operators which are provided by Java. Here you can see I have opened the official Java docs, and you can see a bunch of comparison or relational operators. Both of the terms are used interchangeably. Some people call them comparison operators and some people call them relational operators. So you can see if I want to compare if an object or a value is equal to another value, then I use the double equal sign. If I want to compare for non-equality, I will use exclamation with an equal to, which means not equal to. If I want to do a greater than comparison, then I will use the mathematics greater than symbol. If I want to do the greater than equal to or less than equal to, they again follow the same kind of terminology as we see in mathematics. So this is all we have in terms of value 2. Value 1 has the value 1 and value 2 has the value 2. And then I am trying to compare the value 1 and value 2 variables using the different relational operators we just covered. For doing that, I need to use a conditional operator as well. We will be covering conditional operators in much detail in the upcoming lectures. But for now, you can understand that when we talk about conditional operators, we talk about if and else statement. So if is again a keyword in Java, which can be used to compare things. And the syntax is very straightforward. You write the if keyword and then you write the actual comparison syntax or the actual comparison expression. So in the first example, we can see that I'm writing a condition which says evaluate if value 1 is equal to value 2. I should put a curly braces around here. You can see there are no curly braces here, but that is for a case when you have only one statement under it. But again, I will cover this in detail and I don't want to confuse the audience here. So I will just put curly braces around all of these if statements so that it becomes easy to interpret what is actually going on in these code blocks. As we know that these curly braces are used to define a code block. So the first if block says compare if the value 1 is equal to the value 2. If yes, then this condition will become true and the control of the program will go at line number 10. If this condition is not true, then the control will not go inside 10 because this condition is false. So it will never go to line 10 and it will move to line 11 or 12 instead. Similarly, the next condition is we are comparing the value 1 is not equal to value 2. So this condition will only be true if these two values are not equal or unequal. And if that is the case, then line 14 will execute it. Otherwise, line 14 will not be executed. Similarly, in this condition, I'm saying compare if value 1 is greater than value 2 or not. So if the actual value holded by value 1 variable is greater than the value 2 variable, then this condition will become true and the line 18 will be executed. Otherwise, it will be skipped. Then similarly at line 20, I'm doing the reverse. I'm comparing if value 1 is less than value 2. If that is the case, then line 22 will be executed. Otherwise, it will be skipped. And at last, I'm also showcasing an example of less than equal to operator that you put less than and equal to together. And again, you compare the two variables. Similarly, you can also use greater than equal to variable comparison operator as well in this example. So we have an example of equality, not equal to, greater than, less than, and less than equal to. Let's run this example to understand. So for running the example, I will just right click here, go to run as, and click on Java application. And we can see the output here. So as the value 1 holds the value 1 and value 2 variable holds the value 2, obviously 1 is not equal to 2. So the first condition is not going to be evaluated to true. So line 10 will never be executed because 1 is not equal to 2. Similarly, if I talk about the next condition, which was if value 1 is not equal to value 2, then execute statement 14. And yes, 1 is not equal to 2. That's why we see this particular system.out.println here. We see this printed. Moving on, is value 1 greater than value 2? So is 1 greater than 2? No, it's not. So line 18 will never be executed. Then the next one is value 1 less than value 2? So yes, 1 is less than 2. So line 22 will be executed. And we see the line 22 output here, system.out.println output. Moving on, is 1 less than equal to 2? Yes, 1 is less than equal to 2. So this particular condition is also true and line 26 will be executed. And that's why we see this here. And that's all. So we can see that we are able to use these comparison or relational operators to evaluate different conditions. and we write those conditions using the if block. And again, if you do not understand the if block fully, don't worry, we will be covering the if blocks in detail. But the focus here is in using the operators, the not equal to operators, the greater than equal to operators, less than equal to operators, etc. So I hope these operators give you better understanding of how to use them. Now moving on to the next section of this comparison operators, sometimes we also use some logical terms to do the comparison. For example, if I just move down here and I show you these conditions here, we call them conditional operators. Conditional operators are used to evaluate the conditions like and we use them in two ways. Either we can use it as ampersand or double ampersand, or we can use them as pipe or double pipes. So the idea is basically to evaluate if one condition is true and other condition is also true, or one condition is true or other condition is true. So whenever you want to combine two conditions together, that's where you're going to use these logical operators or conditional operators. You can also use the simple English keywords like and or you can use the logical representation of these keywords. For example, ampersand, ampersand, or double ampersand is equivalent to and. Similarly, double pipe is equivalent to or. So we can use these as well interchangeably. You can use either of these operator representations to run a conditional check in composition, meaning you can compare two conditions saying, okay, if one is true and second is true, or one is true or second is true. So the whole focus is here in and or comparisons. So let's switch back to the IDE and let's look at an example of this to understand this in detail. So I will again take the similar kind of example. Again, I have created two variables here, value 1 and value 2. Value 1 has value as 1 and second variable value 2 has value as 2. And then I'm writing two conditions this time in the same if block. You can see I am writing first condition saying is value 1 equal to 1 and is value 2 also equal to 2. So this whole if condition is only going to be true only if both of the conditions are true. That's the property of and will force that both the conditions on the left hand side of it and the right hand side of it hold true, and then only the whole expression is going to hold true. Even if one of the conditions evaluate to false, the whole if expression will evaluate to false. Similarly, for or conditions, we again write a left hand condition and a right hand condition, and in between we write this double pipe. We can also write or in English. That will also have the same effect, and this will evaluate in a way that this whole expression will evaluate to true if even a single condition either on left side or right side of it becomes true. So or will just need one expression to be true to make the whole if condition true, whereas and will force both of the conditions to be true to make the whole expression as true. So and will require two trues to actually become true, but or condition will require only one true to become true. So if we try to understand this logic, here I'm saying that if value 1 is equal to 1, which is correct, and value 2 is equal to 2, then make this condition as true. So yes, in this case, this condition will evaluate to true because value 1 has value 1 and value 2 has value as 2. So it will print the line 10. Whereas in the next condition, I'm saying evaluate if value 1 is equal to 1 or value 2 is equal to 1. So either of the expression if becomes true, either the left side, this expression, or the right side, this expression. Either of the expression becomes true, this whole condition will become true and line 14 will be executed. Line 14 will not be executed only in a case when both of the conditions here become false. For example, if I write it like this, then we know that value 1 is not equal to 4 because it's 1 and value 2 is not equal to 5 because it's 2. In that case, both of the expression will become false and then line 14 will not be executed. If I write it like this, then the left hand expression is evaluated to true because value 1 is 1, but the right hand expression is false. But it's fine. The line 14 will still be executed because either of these side is true, so the whole expression becomes true. Similarly here, and will require both of the expressions to be true, and if either of them becomes false, then the whole expression becomes false. So in the current state, line 10 will be executed, But if I change this to this, then the left hand side of this ampersand will evaluate to false, and the whole expression will evaluate to false in that case, and line 10 will never be executed. Let's try to run all of these scenarios to make a better understanding of this. So in this case, both of the conditions should work fine. So I will just right click and run as Java application. And yes, we see this line 10 being printed, and we also see this line 13 being printed. So both of the lines are printed correctly. Both of the conditions are evaluating to true. Now let's try to play around with it. Let me change this value to 4. So now value 1, this left hand side expression is false, which should make the whole expression as false, and it should not print the line 10, which is this statement. So let's run this program and see if that works. Yes, we see that this particular line is not printed now because this whole expression became false because the left hand side of this expression became false. Similarly, in the OR case, either of them have to be true. You can see currently value 2 equal to 5 condition will actually result in a false condition because this is not a true. Value 2 is actually 2, not 5. And still we see this particular expression because either of them have to be true. If I make both of them as not true, now both of the conditions on the left hand side of pipe and right hand side of pipe are false conditions. What will happen now? Nothing will be printed. The reason for that is that value 1 is also that this condition is also false, and value 2 condition is also false. So the whole expression became false, and this was already false. And let's get started with bitwise operators. Now, bitwise operators are very less commonly used in the Java programming world. Generally, we don't use them, and generally we don't need to use them. You would generally use them when you are doing really complex bitwise calculation where you need to manipulate the bits. Now, what are actually bits? So if you remember when we talked about the integer type variables, we talked about how much memory each of the variable type or data type was going to consume. We said that this will take 1 byte and this will take 2 bytes, etc. 1 byte is basically made up of 8 bits, and bits are nothing but positions where either a 0 is stored or 1 is stored. Actually, the whole machine will convert your whole program ultimately in zeros and ones, which are nothing but bits. So if you want to do the manipulation at that level, so now you can understand you are actually working at right at the machine level understanding. So if you want to manipulate the bits which are going to be understood by the machine at that level, then you can use bitwise operators. But like I said, generally we don't need to use them. Now, when we talk about bitwise operators, there are multiple ways in which we can use them. We can use them with the standard AND or OR operations. If you remember, we covered this AND or OR operations in the previous lecture. You see a difference here that in case of AND, we are using a single ampersand and not double ampersand. This is one of the concepts which we did not cover in the previous lecture, and I would just like to brief you about this concept that if you use double ampersand, that is also called a short circuit operator. And if you use a single ampersand, that is called a standard operator. To build an understanding about this, I will just quickly recap of what we covered in the last lecture, and we'll try to explain these concepts as well. So let's go to the logical operator demo. And here, if you remember, there were 2 ampersands and 2 pipes. This is also a valid expression. A single ampersand is also a valid expression. The only change is, in this case, even if the left hand condition evaluates to false, still the right hand condition will be evaluated. Although we know that in case of AND, either of the expression needs to be false and the whole expression becomes false. So Java provides an advantage with that if you use double ampersand, and if the left hand operation becomes false, then it will not cover the right hand operation. It will not even evaluate the right hand operation because it doesn't matter. If the left hand operation has already returned to false or evaluated to false, then no matter whether right side is true or false, the whole expression is still going to be false, right? That's the property of AND. One of the side has to be false and the whole expression becomes false. So why evaluate two sides? Why waste the memory in evaluating the right side when the left side has already turned as false? Java takes advantage of that, and that's why if you use double ampersand, you save a bit of processing power of your computer by just evaluating the left hand condition. And if the left hand condition is false, it will skip evaluating the right hand condition and just make the whole expression false. But if you use this, a single ampersand, then both sides of the expression will be evaluated irrespective of their output. So in this case, even if the left hand expression is false, it is still going to evaluate the right side expression. And similarly, it works for the OR case as well. In this case, in OR case, as we know, if one of the condition is true, the whole condition becomes true. The whole expression becomes true. So if the left hand side becomes true, and if you use a single pipe, then it will still evaluate the right hand side. But if you use double pipe like this, then if the left hand side becomes true, then it knows that it does not matter if the right hand side becomes true or false, because ultimately the whole expression is going to be true if either of the side is true. So if the left hand side is already true, it will not evaluate the right hand side, and it will say the whole expression is true. That's why you see the single ampersand being used for bitwise, just to explain why it is used and how it is used. For OR operations in bitwise, you use this cap or whatever you want to call it as. And for the inclusive bitwise or operation, you're going to use a single pipe. You also use some shift operations where you shift the value of bit of a particular variable to either left or right. Again, these are again very complex calculations. If you want to use that, please read about this and use that. But in today's demo, what we are going to cover is the and or examples of bitwise operations. So here I have again created a class called bitwise operator. I have a public static void main method. I have two variables here, which are int a equal to 5 and int b equal to 7. Now these 5 and 7 are actually stored as bits, as zeros and ones in the computer's memory. So how they are actually stored? They are stored in a standard bit representation, which you may have studied in your mathematics. If to give you a recap, this 5 will basically be written in the memory as this 0 1 0 1, and it starts from here. 2 raised to power 0 into 1 becomes 1, 2 raised to power 1 into 0 becomes 0, 2 raised to power 2 into 1 becomes 4, and 2 raised to power 3 into 0 becomes 0. So 0 plus 4 plus 0 plus 1 becomes 5, and that's how 5 is displayed to you. Similarly for 7, 2 raised to power 0 into 1 is 1 plus 2 raised to power. And now if you try to do this, if you try to write this condition, you can also write the condition into a system.out.println block, and it will basically evaluate this condition. So now if you say A and B, in this case, this is going to do a bitwise operation because this is bitwise operand. It is going to do a bitwise operation, and what would be the result if you do an AND on this? So again, use the same logic as if in case of AND, if 1 is false, then the whole expression is false. So 0 and 0 becomes 0, 1 and 1 becomes 1, 0 and 1 becomes 0, because 0 means false and 1 means true. So if either of them is false, the whole evaluation becomes false. So that's why 0 and 1 becomes 0, and 1 and 1 is always 1. The value of this is again 5, as we already have evaluated. Similarly, if we do a bitwise OR, and if we do this, again we are doing an OR operation. So 0 or 0, or basically false or false, becomes false. True or true becomes true. False or true should be true because one of them needs to be true. So this is false, but this is true. So the whole value becomes true. And finally, true or true is also true. So this is the final bitwise OR result. And if we convert this into an integer representation, that becomes 7, because 2 raised to power 0 into 1 is 1. 2 raised to power 1 into 1 is 2. So 2 plus 1, 3, plus 2 raised to power 2 into 1, which is 4. So 4 plus 2 plus 1, which is 7. And plus 2 raised to power 3 into 0, which is 0. So 0 plus 4 plus 2 plus 1 becomes 7. And that's how you get actually 7. So let's see if we get 5 or 7 in this bitwise operation. Yes, we can see the values as 5 and 7. So this is a bitwise operation happening. Similarly, you can also use the shift operations where, in case if you're using this particular kind of representation or this particular kind of representation, they are called left shift and right shift operations. So if you use this in front of a variable, then for example, this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. So that's how the whole value is going to shift. Whole bits are going to shift one by one towards left. Similarly, if you're using the right shift, then all the bits are going to be shifted towards right by one bit. That's the whole concept of left shift and right shift bitwise operations. And if you want to know more about this, please read some official examples from the Java doc and some other examples available on the internet to build an understanding on this.
And with that, we have come to the end of this tutorial. If you guys feel that we have missed out on some important topics that we were supposed to cover in this tutorial, then please feel free to drop them down in the comment section below and we'll have your questions answered. If you guys like this video, then do give it a thumbs up. Please comment your doubts below, share it with your friends, and don't forget to subscribe SimpliCode. Thank you.